Hello, Algebra 2. Today we're talking about Chapter 2, Section 4, which is all about writing linear equations. I'm hoping a lot of this is review, but let's get to it. Here we go. Our goals today are to write an equation of a line given slope and a point on the line, and write an equation of a line parallel or perpendicular to a given line. So, two equations that are going to be important for us today. Both are helpful in different situations. Our slope-intercept form, this is one that a lot of people remember first. Y equals mx plus b, where m, we know, is the slope, and b is the y-coordinate of the y-intercept, the y-coordinate of the y-intercept. This one is very, very useful if we have the slope and the y-coordinate of the y-intercept. If we have those, this is a super easy one to use. This one's also our favorite when we are graphing because it's super easy to use, just to go to the y-intercept, use the slope, make the line, like that. The other one is point-slope form, which is, I argue, more versatile than slope-intercept form. It's y minus y1, that's a subscript 1, equals m times x minus x1, where m, once again, is the slope, just like it was over here. But over here, the y1 and the x1, this is a point on the line. So the x and y coordinate on the line. In both of these situations, the y and the x here, they are just going to stay a y and an x. Nothing else gets plugged into those. Point slope is super helpful if you have 2 points, or if you have the slope and 1 point that is not the y-intercept. I think this one's more versatile, in my own opinion. We can use more points, not just the y-intercept. But really, you could use either of these at any time. So let's go through a couple examples. First, I would like us to write an equation in slope-intercept form that has a slope of 4/3 and passes through 0, 4. All of these are going to ask you for slope-intercept form because, like I said, it's our favorite for graphing. Most people like seeing linear equations in slope-intercept form when they're not in standard form. I think slope-intercept form, again, is easier to look at when we're looking at what the line is actually doing. So I like slope-intercept form. All these are going to ask us for that. So here we go. This one's super easy, right? I know y equals mx plus b. There's my slope. It's 4/3. The x and the y stay put. My y-intercept is right here, plus y-coordinate of the y-intercept, 4, and we are done. Easy as that. So slope-intercept, super easy if they already give you the slope and the y-intercept. Let's do another. How about we write an equation of the line in slope-intercept form that passes through 0, -6, and -4, 10. So a little bit different this time. They don't give us the slope, but we can find it pretty easily. So take a minute, check this one, do this one yourself. What is the equation of a line that goes through these 2 points? And let's go over that now. So here we go. This is my y-intercept, so that's nice, but I need to know what the slope is first. If I do the slope, I have, from last section, I know it's going to be the changes in the y over the changes in the x, so that's -6 minus 10 over 0 minus -4, -16 over 4, that gets me -4 is my slope. So that's important. And then that's my y-intercept. Here we go. Y equals mx plus b. Y equals mx plus b. There we go. If you wanted to, you could make this just subtracting 6. That would be fine. There we go. Hooray. So both of those, it was really easy to use y equals mx plus b. Let's go for some more examples. How about this one? There we are. Write an equation in slope-intercept form that passes through 2, 3 and has a slope of 1/2. Now in this case it's a little bit different because this is not the y-intercept, so using y equals mx plus b might not be the easiest thing for me to do right now. I could do it if I really wanted to, but I'm just going to use my point-slope form instead. Like I mentioned earlier, I think it's more versatile. So let's do that here. Y minus y1 equals m times x minus x1. Y stays put. This y is the y-coordinate of the point that I'm given. M is my slope. X stays put. x1 is the x-coordinate of the point that I'm given. Then I just need to simplify because I do want it to be in slope-intercept form by the time it's all said and done. So y minus 3 stays put. I'm going to distribute this guy in. I get 1/2 x minus 1. 1/2 of 2 is 1. Then I'm almost in y equals mx plus b form. I'm just going to add this 3 to the other side. I get y equals 1/2 x plus 2. Y equals mx plus b. There we go. So I know my slope is 1/2. I know my y-intercept is going to be 0, 2 based on that. And that's a really good way for me to graph this. So in slope-intercept form, there you have it. Hooray! All right, last one. For examples like these, we have write an equation in slope-intercept form that passes through these 2 points. Neither of them are the y-intercept. So I need to first find the slope between these, and I'm going to say then use my point slope form, since neither of these are my x-intercept. So first I find the slope. Change in y's over change in x's, that's going to be my slope. -1 minus -3 all over -2 minus 2. I get, subtracting a negative is really adding a positive, I get 2 over -4, so I get -1/2 is my slope. Does not matter which one of these I use, 4-point slope, you'll get the same answer either way. Y minus y1 equals m, x minus x1. My slope is -1/2, so I have y minus, I'm just going to use the first point here, minus -1 equals my slope, -1/2, x minus -2. It is important that these 2 points, these two xy coordinates, go together. So notice I used the -1 and the -2 from this single point. I didn't mix and match. So knowing that, I'm just going to simplify this a little bit. That's really y plus 1 and -1/2 x plus 2. When I distribute, I get -1/2 x minus 1. Subtract that 1, subtract that 1. I get y equals -1/2 x minus 2. There is my y equals mx plus b form. My slope is -1/2. I see my y-intercept is down at -2. There we go. Okay, so now let's talk a little bit about some geometry words that are going to be helpful for us with lines. Mentioned them before. We are talking about lines that are parallel and lines that are perpendicular. Hooray. Parallel, we're going to use the symbol like that to show them. Usually perpendicular, we use this symbol, it's an upside down T. These are showing us kind of what's happening here. We know that parallel lines never ever touch. They run next to each other like railroad tracks forever. Perpendicular lines, if they're perpendicular, they are going to cross each other, specifically at a 90-degree angle. That's important. Not percent, silly me. 90-degree angle. One more time. 90-degree. There we go. 90-degree angle. Now, lines that are parallel have slopes that are equal. Perfectly equal. Super easy. Lines that are perpendicular have slopes that are opposite reciprocals. Opposite reciprocals, which means the slopes multiply to -1. So now you might be reading that and say, wait, what, huh? Opposite reciprocals. Opposite, one's positive, one's negative. Reciprocals, if you have A over B, you're going to have B over A. That's what reciprocals mean. So real quick, let's say I am given the slope -7, and I want to find the parallel and perpendicular slopes of that. So take a minute, answer this one on your own. What is the parallel slope to -7? What is the perpendicular slope to -7? So let's talk about these answers. Parallel, they are equal, so my parallel slope is -7. My perpendicular slope is the opposite reciprocal. Well, if it's -7, I want positive reciprocal 1/7. Those are my two slopes, a parallel version, a perpendicular version to the slope, -7. So let's talk about these last two examples real quick. Write an equation in slope-intercept form, there it is again, that passes through 5, -6 and is perpendicular to, and again there's my symbol there, y equals -3 halves x plus 7. So I know it's perpendicular, I know it has to pass through 5, -6. So something that's important here is this point, obviously, and this slope is important, but this +7 really isn't important at all. That's all I need there. So if it's perpendicular to -3 halves, perpendicular to that is going to be +2/3. So I need it to be a slope of 2/3 going through the point 5, -6. I'm going to use my point slope form for this one. I have y minus -6 equals 2/3 x minus 5. So I'm going to get a little funky with the decimals here, but that is okay. I have y plus 6 equals, when I distribute, 2/3 x minus 10/3. I'm going to subtract this 6, which is really 18/3. So just a note to self, that's 18/3. So I have 2/3 x -10/3 minus 18/3. I have -28/3. And there's my perpendicular equation of this equation, and mine goes through this point. There we go. And it gets a little funky with the decimals, with the fraction, but that is okay. Last one, write an equation in slope-intercept form that passes through 3, 7, so again, that's important, and is parallel to, oop, I'm sorry, you guys couldn't see that last part. Just realize that. There we go. There's the last part of the question. Sorry about that. Last one more time. That point is important, that 3, 7, and it is parallel to 3/4 x minus 5. Once again, the fact that this y-intercept is -5 is not important to us. There we go. But this slope is. So if it is this point, that slope, I'm going to use point slope form again. Y minus y1 equals m times x minus x1. I have y minus 7 equals 3/4 x minus 3. I'm going to distribute here. I get y minus 7 equals 3/4 x minus 9/4. I'm going to add that 7 to the other side, which I know is actually 28/4. That's something I know 7 equals. So this is y equals 3/4 x -9/4 plus 28/4. I am going to get positive 19/4. Again, a little weird with the fraction there. Not that bad of a decimal on that one, but there you have it. So there we go, all about lines. And I think that's about it. Yeah, so that's section 4, writing linear equations. Make sure you know slope-intercept and point-slope forms. Know them by heart, know them, love them, use them. All right, we'll talk about all of this in class another time.